a system exhibits a discernible behavior over time as a result of the interaction between the elements of the system. And that behavior over time is usually referred to as an emergent characteristic, along with the same comments that were made about a system exhibits characteristics not produced by any subset of its parts. So it's that nature of the interaction between the elements which ends up presenting a discernible behavior over time. And that behavior over time can actually be represented as a time graph, so that the graph shows the way that certain elements of the system have in fact changed over time. And it's the behavior over time is the result of the interaction of the components, so that if it wasn't for that interaction, this behavior wouldn't be produced. And often it is that set of interaction that produces a behavior that creates a situation that we perceive that we in fact need to pay attention to. Though what happens more often than not is that we see the situation that develops as an event, and the reason for that is simply because we're off paying attention to other things, so that when that event occurs, the event is simply something that gets our attention, whereas change actually happens both over distance and over time, and it occurs over some time period. So if we actually look at the relevant time frame, we can in fact realize that there is a pattern of behavior that has actually led up to the situation that we perceive. And these patterns of behavior, or behavior over time graphs as they're often referred to, are extremely important when we do simulation models, because it is in fact that the behavior over time that we use as a reference, what's called a reference mode, to help us validate the model that we develop. Because when we develop the model, it should in fact produce the reference mode of the system that we're investigating. Though that behavior over time, sometimes you can do research to identify the individual elements or the data points over time, and then there are times when the best you can possibly do is to freehand that behavior over time based upon the stories that people tell in the organization, simply because the data is not there to construct the actual behavior over time graph. Though as I said, it is in fact important to develop that behavior over time graph for the relevant aspects associated with this situation, so that when we develop simulation models, we have a sense that the model is in fact representing the reality of the interactions that are responsible for the situation. So we use patterns of behavior to give us an insight into the models, the way things that have evolved over time, and to help us validate the models that we develop. And there are in fact some patterns of behavior that occur on a very frequent basis. And we'll get into these in a lot more detail, the structure responsible for these, when we talk about system archetypes. But the goal-seeking structure, which occurs when the system is in fact trying to achieve some goal, so that it starts out and it changes quite readily, and then as it gets closer and closer to the goal, the rate of change slows down until such time as it actually, the change stops when it finally reaches the goal. This is the result of balancing feedback in a structure. The other type is exponential growth, where something seems to increase very, very slowly for a period of time, but then it begins to increase faster and faster, until this curve would actually in time become almost vertical. And this is the result of positive or reinforcing feedback in a structure, and it produces exponential growth. These two structures, or these two patterns, appear over and over and over again. Well, that's probably why we call them recurring patterns, right? Then there's an S-shaped growth curve, which begins in something that looks like an exponential growth curve, but then it begins to not change as readily, and then it levels off and begins to look more like a goal-seeking curve. This is usually the response of some limits to growth structure, and we'll talk about that particularly in specific when we get to archetypes. So though the thing is, there are a certain set of patterns that occur over and over again, and there are typical structures that are responsible for those patterns, so that if we identify a pattern, we can then go ahead and investigate to see, is it actually that structure that's responsible for this pattern of behavior, and if so, we have an immediate insight into what the structure is and how to deal with it. The last one that occurs over and over again is an oscillation where something changes in one direction to a point, and then it turns around and moves in the other direction, so that rather than stabilizing on something, it moves back and forth. And at times you'll find something begins as an oscillation, but then it dampens out and actually comes to achieves a goal, or maybe it actually gets worse over time, and as depicted here, it stays the same oscillation on an ongoing basis. And we'll talk about structures that are responsible for creating those types of patterns. So behavior over time is something that we pay attention to because it helps us develop an insight into the structure that's responsible, that the structure that's actually the interactions responsible for the situation that we want to understand and figure out how to deal with. So hope this has been informative. See you in the next video. Bye.